Okay, college mathematicians. This is how I do my lectures with my calculus class. Actually, they're all online on video, and then during class, we just ask questions and go over example problems and do some troubleshooting. It works really well for calc. I've never tried it for college math, but I think we're gonna, because of the snow day today, we're gonna have to try it. Um, to stay on schedule, we're going to have to cover the stuff a little faster. So I'm going to put all the stuff you need online for chapter 10. I hope you have time to watch these videos, and then we can um, just kind of troubleshoot stuff on whatever the next day is, Thursday. Now, usually it takes me about 6 hours to prepare these. By the time I make notes and record and edit and upload all that stuff. So I'm just going to kind of wing this by the seat of my pants. So it's not going to be great. It's not my best work, but I wanted to get it to you guys quick. So here it goes. So the whole topic here is graphing systems of equations. And I know that sounds really intimidating, but it doesn't need to be. So we're going to do what's called graphing a system of equations. Okay. And what that is, so I'll start out with a little story. The story involves two people. You've probably never met them or even heard of them. But one of this guy's name is Matt. Right, Matt's a nice guy. And then in green, we'll do it in blue. Over here we have this other guy whose name is Patrick. All right, now Matt and Patrick get along really well, but sometimes they have a disagreement. Okay, for instance, one of their disagreements, they're both good mathematicians, and Matt will oftentimes say things like, he's got this really strong opinion about x's and y's, and that he always says that y has to equal 3x minus 2. Right? Matt just likes y to equal 3x minus 2. So if you have a y, it has to have an x that makes this thing work. Patrick, on the other hand, right, he's kind of an older guy, spent some time in Chicago, so he has a little more pessimistic attitude towards life. Well, his approach is that y always has to equal to negative x, right? Everything's always negative with this guy. And he says y always should be negative x plus 2, right? Now, the question is, which I'll write here in black, can these two ever both be happy? Right? So that's what we're going to try to do, is see if we can make them happy. Now, it turns out that determining happiness is easier done when you have a picture. So we're going to draw a picture of this, and it just so happens I've got this little picture of these points here. So we're going to move this down here and kind of make this a little bigger. Nope, that didn't work so hot. Make that a little bit smaller. Move that down here. Okay, good. So first of all, I'm going to draw a picture of all the places, all the possible combinations of x and y that make Matt happy. So we need to do a little review. We knew that the slope equals 3, right? That comes from right here, that coefficient times the x, equals 3 over 1, right? 3 over 1 is the same as 3, and that equals the rise over the run. Okay, so the slope is 3. We also know that the y-intercept of this guy, Matt's intercept, is what? Negative 2 here. Negative 2. So the way we can draw a picture, we learned some faster ways to do this rather than making a table of values. So I'm going to skip right to the faster way. I'm first going to draw the y-intercept, which I know is down here at -2. So this is the y-axis. I better draw that in black so we don't think it's Matt's axis. This is the y-axis and this is the x-axis. And so now we can draw a picture of all Matt's points. We know his y-intercept, where it crosses the y-axis, happens at -2. So it happens there. And the slope, the rise over run, is 3. So we can go up 3, run over 1. Up 3, over 1. Up 3, over 1, like this. It also works the other way. We can go back 1, down 3, like that. Back 1, well, we ran out of room there. So we can draw a picture, a pretty nice picture of all the points that'll make this guy Matt happy by kind of drawing down here like this. And it goes like that. Okay, so we'll make a note here. This is a picture of all points for Matt. Okay, the red line is a picture of a bunch of points. You know, for instance, this point makes him happy, this point makes him happy, this point makes him happy. Even some of these points in between, you know, the big points, they make him happy. So that's what Matt likes. All right, now in blue, we can do the same thing here. This time the slope is a little more subtle. The slope here equals -1, which is the same as -1 over 1, and that also equals the rise over run. And the y-intercept equals +2 for this one. So if I were to stick a 0 in for x, or if I was to stay on the y-axis, so I don't go left and right at all, then I'm just going to say y equals 2. So I draw a point here. Okay. Now my slope is -1. My rise over run is -1 over 1. So I go down 1 over 1, 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 and we can kind of see these are making a nice straight line. And I can again draw a picture of all the points that make this guy Patrick happy. So it's really hard to draw straight lines with the tablet here. So here's all the points. So we'll call these Patrick's happy points. Right, or all these blue ones. Now the question is, you know, are there any points that make Patrick and Matt happy? All right, you may be able to hear my son protesting in the background. I'm not sure exactly what he's protesting, but you get a spur of the moment video lecture, and that's how it works. So here's Patrick. That's Patrick, and then Matt was in dark red, I think. Yeah. Now it turns out there is a point, right? So the answer to this is yes. So here's a point where if I go to 1, 1, 1, 1, this point here, that makes them both happy. So let's check that. In red, or we'll do blue over here. In blue, we said that y equals -x plus 2. So I'm going to plug in 1, 1. And we say that 1 equals -1 plus 2. So 1 equals 1. So yeah, that works. That's cool. Now we'll do it over here. same thing where we said Matt's points are y equals 3x minus 2. And we plug in 1, 1, and then we say 1 equals 3 times 1 minus 2, and so that's 1 equals 3 minus 2, 1 equals 1, and that works too. All right, so we call 1, 1. One comma 1, and that is really, what does that represent? That represents x and y. The solution to the system of equations. Because when we just have 1, there's an infinite number of points that will make Patrick, or this is Matt, that'll make Matt happy, right? He's an easy guy to please, right? As long as x and y fit this equation over here. Anything, we can keep going up that way, likewise we can keep going down this way, and he'll always be happy, right? There's also an infinite number of points, that'll make Patrick happy. We can just keep going millions and millions of points that way, and we can keep going millions and millions of points this way, and he'll be happy. But there's only one point that works for both equations. And Matt and Patrick together make a system of equations, and this point right here is the only one that works for them both. Okay, so that's another, that's an example of solving a system of equations like this. Okay, so let's do another one of these, and I'm going to have to, these are a little harder to make up in my head, so I'm going to cheat here. So let's see, x plus y equals 7, and x minus y equals 5. Yeah, that'll work. So we've got, you don't want to see my email there. You want to go to this. Okay. So this time we've got another couple of equations. We have x plus y equals 7, and then Matt's equivalent equation is x minus y equals 5. Let's make sure I got that right. X plus y equals 7, x minus y equals 5. Okay. Now, the other one was easy to do with this slope-intercept method. This one is going to work a little bit better if we use this intercept method. So we're going to use what's called the intercept method. So in blue, we're going to say that if x equals 0, then we say 0 plus y equals 7. So that means y equals 7. And then if we say if y equals 0, and these are two different things here, we say x plus 0 equals 7. And then so that means x equals 7. So that one turned out to be pretty easy to do. Likewise, when we do this one over here, fairly easy, we say if x equals 0, we say that, let's see, 0 minus y equals 5. And so we have negative y equals 5. This is supposed to be a y. And so we have to divide by negative 1, divide by negative 1, divide by negative 1. And so we get y equals negative 5. And if we say if y equals 0, this one's easier. X minus 0 equals 5, so x equals 5. Alright, so now we have some intercepts, so let's draw a picture of this. Let's plug it in there. And this goes down here roughly. We make that as big as we can, and since most of them are up, y is -5, well, we'll just put it right there. So in the blue one, we're going to take a look at this. If x equals 0, remember this is the x-axis and this is the y-axis. If x equals 0, then y is going to be 7. So if x equals 0, which means we don't go left, right at all, y becomes 7. So it's 1, 2, 3, 4, 5, 6, 7, all the way up at the top. Barely fits. And if y equals 0, x equals 7. So that's kind of an interesting one, the way it works. 1, 2, 3, 4, 5, 6, 7. It goes over here. And then we draw in a line. And if we're really good, we'll hit the other point. Hit it. Excellent. And this goes infinitely far this way. So the blue line is a picture of all the points that will work for this. So x plus y equals 7. Let's see, does that work? So how about this one? 2. If x is 2, y will be 1, 2, 3, 4, 5. 2 plus 5 equals 7. Sure enough. What about if it's 6? X is 6. 1, 2, 3, 4, 5, 6. And then y is 1. 6 plus 1 equals 7. All right, so that works. Cool. Now we go over here to the red one, and then we say if x equals 0, y equals -5. So if x equals 0, y equals -5. So x is 0, which means we don't go left and right at all. And 1, 2, 3, 4, 5, like this. And then if y equals 0, so we're not going up and down at all, x equals 5. So 1, 2, 3, 4, 5, like this. Yep. So that goes like that. And then again, we can draw a line that tries to go through both points. I got to draw this very carefully with my tablet. And there's this red line is a picture of all the points that make this work. And it looks as though we might have a winner here. So let's check that out. So it looks like what point is this? Let's see, 1, 2, 3, 4, 5, 6, and 1. So that's the point 6, 1. It looks like it might work. So it looks like 6, 1 might work. Let's check. So in the blue corner, I didn't really mean that to be blue and red like that, but it's fun to say. In the blue corner, we have 6, or we have, let's see, x plus y equals 7. Does that work? 6 plus 1 equals 7. 7 equals 7. That works. And in the red corner, all right, let's see, we have x minus y equals 5. X minus y equals 5. And then, so that's 6 minus 1 equals 5. Ooh, 5 equals 5. So that works too. Okay, so both of those points, or this one point, 6, 1, works for both equations. And we can check that over here. So this checks out. Okay, so that works. Now, we're going to take it, I'm going to leave that as enough of an example. And we're going to try to solve the same system with a different way. All right. So I'm going to say x plus y equals 7, x minus 5 equals, x minus y equals 5. Let's see if I can remember that when I flip to the next page. X plus is 7, minus is 5. So here again, in blue, I don't remember if the colors now, but x plus y equals 7. This time it's a nice shade of dark blue. And in the red we have x minus y equals 5. Okay. Now we have to take a step back and think about this. How does this work? This is saying, what is the blue thing saying? Is that in blue, I'm going to say that this thing here, x plus y, is the same as this thing. So the circle equals the square, right? The circle and the square are two equal things, right? They're equal things. Likewise over here, I'm going to say that this thing, I don't know what's in the circle because I don't know what x and y are. And I know what 5 is, but I'm just going to put a box around it anyway. I'm going to say that my circle equals my square here. Okay. So if my blue circle and my blue square are equal, I should be able to add something to both sides and they'll still equal. As long as I add, I could add, 5 to both sides or 3 to both sides. And, we've done this before. As long as I do the same thing to both sides, they remain equal. But I've got to do the same thing to both sides. So I'm going to take down here, I'm going to say that my circle equals my box. Right? And I'm going to add something to both sides. I'm going to add to this side, I'm going to add another circle. Which should mean that I have to add a round circle to the other side. Right? I got to add a red circle to both sides. But I know that a round circle, a red circle and a red square are the same. So I could add a red box to this side. I added the same thing to both sides, right? I know that a red circle and a red box are the same. So it's like I added a 5 to both sides, or I added a 9 to both sides, or whatever. In this case, I actually added a 5 to both sides. And those things, if I add the same thing to both sides, it's got to remain equal. So I could say then that, and let's draw a line here. We'll do a blue circle plus a red circle has to equal a blue box plus a red box. Okay. So I hope you guys understand that. You can hear Wally's getting a new diaper. That's his favorite time of day right now. New diaper, there's nothing better than that. Nice, dry nether regions. All right. So let's go through and actually, I hope you believe this, that if I add the same thing to both sides, right, that this whole thing remains equal. So let's write it out. And I'm going to say that if x plus y equals 7, and I'm going to add to that, the red stuff, x minus y equals 5, and I add these together. Well, if I add them together, what's x plus x? 2x. What's plus y plus minus y? A positive y plus a negative y, that equals 0. And what's 7 plus 5? 7 plus 5 is 12. So, I started with one equation. I added the same thing to both sides because I know that x minus y is the same as 5. X minus y is the same as 5. So I should be able to add this thing to this, and I should be able to add this thing to this, and they should still be equal. So now I know that 2x has got to be equal to 12. Right? And what does that mean? Most of you can probably guess this from here. Divide both sides by 2. That means x equals 6. So now I know what x is. And if x equals 6, I'll have to go up here. Sorry, this is going to be kind of a wasteful step here. Well, no, I'm just going to, for the sake of saving, computer paper. If x equals 6, I can say that 6 plus y equals 7. So that means I can subtract 6 from both sides, subtract 6 from both sides. So now I know that this goes away. So y equals 7 minus 6 is 1. So I can, without even drawing a picture, I can now tell you that the solution to this system is 6, 1. And we put a box around that answer. Green box for success. Right? And that's just what we learned on the other page here. We learned that 6, 1 works by drawing a picture. Well, we can do the same thing by adding two equations together. All right. Let's do another example like that. Let's do it in black, however. So another example is, I guess. Oh, look at, hey, they got 6 and 1 too. So cool. We must be pretty good mathematicians. This one's a little trickier here. What the heck is this? 3x plus 8y equals. Where'd that come from? Was that a different example? No. Yeah, where the heck did this come from? Oh, B. Here we go. This one. No, that one's too easy. Let's do an easier. Let's do a better one. You guys are too good for that. That's child's play. Should I see 2x plus y equals 7 and x plus y equals 3? I think we can still do better than that. Well, let's find out. Oh, here's a good one. Here's a good one. So we want 2x plus 3y equals 1. So we've got 2x plus 3y equals 1. And then we also have 3x plus 4y equals 2. So 3x plus 4y equals 2. All right, well, let's take a crack at this one now. And we discovered that before, when we added these two equations together, I don't want to erase. When I added the two equations together, my y's went away, so I was just able to get the x. Once I knew what x is, I could plug it back into either one of the equations to get y, and that gave me my solution. So it should work here, right? So we have 2x plus 3y equals 1, and then we're going to add that to 3x plus 4y equals 2. Add those together, so now we have 2x plus 3x is 5x, plus 3y plus 4y is 7y equals 3. So we didn't really make a lot of progress there. Yeah, that didn't do us much good. So let's, what went wrong here? I noticed that when I added these two together, the 2 and the 3 didn't cancel out, obviously. The 3 and the 4 didn't cancel out, obviously. So we need to do some work. Let's say I want the x's to go away. All right. So what's a number that, yeah, so I'm going to multiply this top one. I'm going to take this one, this equation. I'm going to multiply both sides by, just for kicks, I'm going to multiply by 3. So when I multiply by 3, I get 6x plus 9y. You can hear, I don't know what's going on over there, but Wally's liking it, equals 6. All right? So, oops, that's not right. Sorry. So I was listening to my son. It's right. I love listening to him. Like when he's really happy and he talks, I like to listen to him talk. But I can't do that. So, oh yeah, 3 times 3 is, yeah, this is the problem here. Sorry guys, but you're getting the first take here. That's how it goes. So, 2x times 3 gives me 6x. 3y times 3 gives me 9y. And then 1 times 3 gives me 3. Right. I'm going to take this one. We're going to have to do kind of an end around here. I'm going to multiply by -2. So 3x times negative 2 will give me a negative 6x. 4y times negative 2 gives me a negative 8y. 2 times negative 2 gives me a negative 4. Now I'm going to try this addition again. I'm going to try to add my two new equations together. I've got 6x plus 9y equals 3. I also have negative 6x minus 8y equals negative 4. If I add these two together, ooh, look at this. 6x plus negative 6x, that goes away. 9y plus a negative 8y, think about that. What does that give me? 9 plus a negative 8, that's the same as just positive 1y. And a 3 plus a negative 4 gives me a negative 1. So I now know that y equals negative 1. I'm going to put a dotted box around that because that's going to be pretty useful for me in a little bit. Now I can take this, now that I know that y is, a y that's going to make both Matt and Patrick happy, is going to be 2x plus 3 times negative 1. Wow, Wally is really having a good time over there. I wonder what's going on over there. What's going on over there? You guys just playing on the floor? Or he's eating? Yeah, he's eating. So he's eating vigorously. 2x plus 3 times this y value that I figured out is negative 1. And that's got to equal 1. Right? So I took this. I'll make a little note here in light blue. I kind of took this equation and I sent it all the way back down here. Now that I know why. And that becomes back in black. 2x 3 times negative 1 is negative 3, so it's minus 3 equals 1. So 2x equals... what am I doing here? I kind of went too fast here because I'm trying to finish up and pretend to be a father for a little bit. 2x, I'm going to add 3 to both sides, so that cancels out this, and then this becomes a 4. So I know x equals 2. Right. Now, if this little process here, I kind of did some steps in my head, kind of. I added 3 to both sides in my head, and I divided by 2 to both sides in my head. All right. If you struggled with that, take some time to think about this. So now, I know that x equals negative 2. Put a little dotted box around that. So I know my final answer will be 2, comma, negative 1. So that's the point that will work for both of these. There we go. Now let's check. If x is 2 and y is negative 1, 2 times 2 would give me 4, plus 3 times negative 1 is negative 3, so 4 plus negative 3 gives me 1. That works. Let's check over here. 3 times 2 is 6, plus 4 times negative 1, that's negative 4. So 6 plus a negative 4 gives me a 2. So this thing works for both equations. All right. So I'm going to leave it at that. No, actually, let's do a quick review. Let's go back to the beginning. What did we do? We graphed a system of equations. And we drew all the points that make Patrick happy. And we drew all the points that make Matt happy. And we discovered that there's one point that makes both of these guys happy, and that's 1, 1. We plugged that point 1, 1 into both original equations and discovered that that works. Okay? So, that's the solution. Now, here's another one. X plus y equals 7, x minus y equals 5. We graphed these two. This time we used a different method to graph these two. We graphed the intercept method, but you know what I'm trying to say here. We found the two intercepts of both lines. We drew the line in here, and it looks like 6, 1 might work for both of them. And we check. We plug in 6 and 1 for x and y. 6 and 1 for x and y, and it turns out that works. But then we got creative. We said, well, what if I didn't want to draw a picture? I took the same two equations, and since the blue stuff is equal to each other, that's fine. The red stuff is equal to each other. I can add the red stuff to the blue stuff, and they should still be equal to each other. And I found that when I add these two equations together, I get 2x plus 0 equals 12, so straight away I can get what my 6 is. I'm going to put a dotted box around there. And then I plug my 6 into either one of my equations, and I discover what my y is. So that works there too. But this one was really easy to do. We did a harder example where just adding them together doesn't work, so I've got to be clever. I've got to think, ooh, I can change this 2 into a 6 easily enough. I can change this 3 into a negative 6 easily enough by multiplying by negative 2. Now I've got two equations, still two valid equations. I add these together and I get one of the variables to go away. Now that should give you a big head start, so you can attempt some of the homework, at least the 10.1 and the 10. I'm going to write that down actually. So with this, please attempt 10.1 and 10.2 homework. Enjoy the snow. Okay, that's it, guys. I will see you on Thursday, and we're going to have to keep a brisk pace. So try to spend a little bit of time. These assignments should take you about 30 minutes each, so plan on that. Take care.